All right. My talk today is about the DNSSEC root zone KSK rollover. I'm going to give you some very important piece of information because there is a very important event that's going to happen in exactly 2 weeks on the 11th of October. It's the rollover of the root zone KSK. So let's see what it is about. So as you know, the DNS has a security extension called DNSSEC, which has been deployed and used for around a decade now. Many people are actually signing their zones, and also people are validating signatures on their zone. So how it works, DNSSEC basically is in two components. There is a signing part where people have, where zones have actually cryptographic keys that is used to sign their zones. And then on the other side, there are relying parties, which are basically DNSSEC validating resolvers that validate the signatures to make sure whatever you're receiving has not been tampered with and is coming from the place or the person which is intended to come from. To do DNSSEC, we have two pair of keys. One is called the key signing key, the KSK, and the other one is called the zone signing key, the ZSK. The zone signing key is actually to sign the data in the zone, and the key signing key is used to sign the key, the ZSK actually, and it's the KSK which is going to be rollover in the root zone. So basically, each zone has a ZSK, a KSK, and to build a chain of trust, each zone has to publish their the hash of the KSK in the parent zone. So technically, every zone has a parent, in the exception of the parent zone, which is the topmost zone, which is the root zone KSK. So the root zone DNSSEC KSK is the topmost cryptographic key in the DNSSEC validation hierarchy. And the public portion of the KSK is in the configuration parameter of your DNS validating resolvers. It is where you should be concerned. You should be concerned if you're an ISP and you're running a DNSSEC validating resolver for your customers, for example. If you're a network operator, for example, a university, and you're operating a DNS resolver for your students. System integrators, if you're also developing DNS-related software, if you're a root server operator, and end users. Because if no action is taken by your DNS resolver operator to make sure that they have the correct key, once the rollover is done, or actually before the rollover is done, then you might run into some trouble. So there has been one functional and operational root zone DNSSEC KSK already. It's called the KSK 2010. Actually, it has been the only key so far, and it has not been rolled. We basically roll keys because of security hygiene. The ZSK, for example, is rolled every quarter, the one that is used to sign the data in the zone. And the KSK should technically be rolled every 5 years. So now, almost 7 years later, there is the KSK 2017. So the KSK 2017 was actually generated in 2016, in October 2016. It was published around February last year. So to tell you that the rollover has already started, the process of rolling over the KSK has already started. So what does it mean for people operating a recursive DNSSEC validating server? They have to, as little as review their configuration, or at most, they will have to install the new key. So yes, you're saying KSK 2017, but now we are already in 2018. So what happened? It's not a typo. It's just the results of a delay. So how do you recognize the new KSK, the KSK 2017? That's the key tag 2326. And it's being shown in the form of a delegation signer record, DS record. And that's how it looks like in the root zone. You can actually dig for it, and you will find the key in the root zone. So I can actually started to make plans for the rollover back in 2015. And to make sure that DNS resolvers out there in the wild, because you cannot know how many resolvers there are on the internet. It's almost impossible to count them. So they came up with a standard that was actually standardized at the ITF called the RFC 5011 for automated updates of DNSSEC trust anchors. And recommendations were that operators need to rely on RFC 5011 for them to get the latest key. But the issue was that not all of them have actually implemented this code, and they were not seeing that the pickup and the adoption of the new key as it should have been. So that's how it should have been, actually, the milestone. In green, you see things that have already been done, like creation of the key, putting it online, and also standardizing the automatic updates RFC. And then, but then putting it in production, like using it for signature, has not been done yet. And this is how it looks like now. The signing, using the new KSK for signing will now be done as from the October 11th this year. So why did they actually update the milestone? What changed? So when the rollover started, there was no way to measure the resolver configurations. During the project, a new measure was invented, implemented, and rolled out. And the new measure's results were at best confusing and concerning. So the rollover was paused to have a look at what was happening. So the readiness measure is called Signaling Trust Anchor Knowledge in DNS Security Extension, also known as RFC 8145. So what the standard says is that if you implement the protocol, then you need to communicate the trust anchor material to an authoritative server. So that was quickly turned into code and implemented, but at a later stage. So basically, we started to receive information from those that have implemented RFC 8145 at a much later stage. So if you see on the map here, the green light is the number of sources reporting the trust anchor data. And the red line is the number of sources reporting only the KSK 2010. So these are where we have issues here, because when we started to have some information about the KSK rollover, and basically the one that has only KSK 2010, we got around, here you see the percentage, around 7%. Around 7% here, the percentage is the black line, was reporting only KSK 2010. So that's a bit of an issue. So the people from VeriSign were looking at two different root servers, and they noticed that the number of DNSSEC validators having only KSK 2010 was uncomfortably high. And the results were confirmed by separate ICANN research, where they got feed of data from all the root servers, and the rates that of the number of resolvers only reporting KSK 2010 was on the rise. And why was it on the rise? Is because as soon as people were were implementing and deploying resolvers with the RFC 8845 code, the number of them reporting the KSK was just going up actually. But then they also saw a lot of issues with the code, because you know the DNS is a complex system. Some of the resolvers are either using dynamic addresses, so they will come up and go out. That's why on the graphs, on the graph you see spikes coming at times. So those are due to, for example, because of dynamic addresses. And there are sometimes DNS resolvers are also behind DNS forwarders. And even at times they saw that non-DNSSEC validating resolvers were also reporting their trust anchor material. So there's no point if you're not validating DNSSEC to send your trust anchor data. So the data was not very reliable. So how do you check if your cache is doing DNSSEC validation? You just send a query, for example, a query of DNSSEC fail.org for an A record with DNSSEC. And if the response holds a return code of serve fail, DNSSEC validation is enabled. If the response holds an IPv4 address, DNSSEC validation is not enabled. Here is an example of DNSSEC validation which is enabled. And here is an example of DNSSEC validation which is disabled. So how do you know if your DNSSEC resolver has actually trusted the new KSK? So this is also tool dependent, whether using bind, not DNS, power DNS, unbound. So have a look at this URL. It gives you information about how to check different implementations, how to check if you have the new KSK. So technically, you should see two trust anchors: the KSK 2017, the new one, and the KSK 2010, the current one, which is being used right now, but it will eventually go away. This is how it looks like in bind. So you have the two keys, and this is how it looks like in unbound. You have the two keys which are both valid. And what happens if you have the wrong trust anchor? After October the 11th, DNSSEC validation fails for everything, resulting from an inability to build a chain of trust. All DNS responses will serve fail, even if the target zone is not DNSSEC signed. So have a look into your logs and see if you have any error messages coming along. So if you are not using RFC 5011, that is getting the automatic updates, then you should get the KSK 2017 manually via a trusted source. For example, you can go on the IANA website, or you can dig for the DNS key using just the dig command. And then, yeah, make sure you have the latest key. So in the future, that same RFC 5011, which does automatic update, will be used actually to remove the old key in your system. When are we going to do that? We don't know yet. I suppose ICANN will communicate on that. So some statistics, ICANN in the process of measuring who is actually already capable of signing with a new key, have published some data and have actually extracted some data for Africa. So we had 102 ASNs in Africa in 28 countries that are operating at least a resolver reporting only KSK 2010. The total number of unique IP addresses reported is 1,776, including 7 IPv6 addresses, corresponding to DNS resolvers in those networks. Out of those 1,776 unique IP addresses reporting their trust anchor configuration, 1,628, that is 92%, are only reporting the KSK 2010, and 8% of them are, and the remaining 8% are reporting both 2010 and 2017 Tresenke. Now, if you have a look at DNSSEC in Africa, so these statistics are coming from the EPINIC measurement. They do DNSSEC validation statistic. As you know, statistics coming from EPINIC is based on their ad-based measurement platform. So it is what it's worth. And what you see, for example, here, Tanzania is validating at 7.7%. And there are also 15% is using Google DNS. Those operators from Tanzania appeared in that list of those that are only reporting KSK 2010. Actually, SECOM is reporting both of them, 2010 and 2017. But TTCL data and Zantel are only reporting KSK 2010. So perhaps you guys need to have a look and make sure that you indeed have the correct key now. I can actually contacted many of them that was appearing on their list of those on the reporting KSK 2010. So you might have been contacted already. So what is there to do? If you or one of your clients are running a DNSSEC resolver, make sure you are aware of whether your DNSSEC validating resolvers are performing DNSSEC validation properly, either over v4 or v6. Verify which DNS software you are operating and make sure you have also surveyed all embedded DNS resolvers that are sometimes hidden and operating in the background. That could happen as well, because, for example, if you have implemented software with DNS resolution, make sure your configuration files have the required options to enable automatic download of the new trusted key, and be aware of legacy application doing DNSSEC validation. So if you decide to enable automatic updates, just be mindful that it might take up to 30 days, and you don't have 30 days now because it's going to happen in 2 weeks. So if you see that you don't have the proper key, you need to install it manually. So advice to anyone operating a DNSSEC validating recursive server, prepare now, do not wait any longer. Automatic updates will not have enough time. Update your code and configurations. Those are the places where you can get more information and also engage with the community. And if you have information, and if you have any question, then you can also ask us, and we can point you to the right person at ICANN. I would like to thank Edward Lewis from ICANN, who actually kindly gave me his slides to present. Thank you.
Thanks, Amrish. Mine is really not a question, but maybe just to Bob or Jim Icon. Adiel from our technical team has also published a very detailed blog on SACO ID, which I would also point to you, and gives you much more detail in terms of step-by-step what you can do or what you can anticipate, and looks at all the possible resolvers. So I'll also point you to that for those who are following. But I would encourage us to really strive to be compliant. I think statistics indicate around 25% possible impact globally. I'm not sure, or we can't point out exactly where those people will be. So it is important that we are compliant. Thank you.
Mark Tinker, SECOM. Thanks, Amrish. I think from our side, we got a notification, I think, from ICANN. I'm not sure if it was instigated by anyone or if it's automated, but they managed to pick a couple of servers or resolvers that apparently were out of, what were not up to date. But that was, I think, more than a month or months ago. I think it could have been a transition between, we ran bind, so I think 9.10 to 9.11, something or other. At any rate, it's not that difficult. What I saw is basically a matter of having the most recent resolver.
So you had to upgrade.
Yeah. Well, I think by the time they did the test and from when we had 9.11, it was all done because all the tests now check out across all the resolvers. But like what I'm saying is that the thing is that it's just a case of making sure you have the latest version of your resolver. There's not much else to it.
Yeah.
But interestingly now, because I see the announcements are going out everywhere, so I got an email today from my account manager who's asking us if the customer's concerned about the internet going down is going to be a problem in 2 weeks. So I think it's a case of internal teaching that needs to be done.
I think some communication should be done. More questions?
Are there any more questions?
Thank you.
Thank you, Amrish.